Hello everyone, let's talk about another easy problem on Leetcode today. Crawler log folder, Leetcode 1598. In this problem, we are given the Leetcode file system which keeps a log each time some user performs a change folder operation. The operations are described below. // moves to the parent folder of the current folder. So if we are in the main folder, then it stays the same. // means remain in the same folder, and x dash means move to the child folder named X. This folder is guaranteed to always exist. Then we are given a list of strings logs, where logs I is the operation performed by the user at the ith step. The file system starts in the main folder, then the operations in the logs are performed. Return the minimum number of operations needed to go back to the main folder after the change folder operations. Then they have given some examples as well. So in example 1, we can see that string is D1. So we go to the child name D1 folder, then D2. So we go one level lower. So now the label becomes D1/D2. Then we go to .. So that means we go one level higher. So we come back to D1 again. Then we go to D21, again a child folder. And then we do the // So that means we stay at the same level. So how should we solve this problem? So if you look at it, there are three possible operations. Suppose we are at this point somewhere in the directory structure. If we see .. that means we have to go up. If we see the child name, then we go to that folder. But if we get .. that means we actually come back to the same state. So in terms of directions, there are two directions possible. That is either going up or going down. There are multiple ways to solve this problem. One way can be that we use a stack. Let's see why. So suppose this is our main folder, then we got D1, then we got D2. Now suppose we got / as an operation, then we will stay at the same position, right? So that doesn't change the label at all. So we can ignore them for now. And if we get .. so that means we go one level up. So we don't go one level up from any of these places, right? We go up from the D2 location. And this was the latest folder we actually came in, right? So this gives the idea of like last in, first out kind of operation. So this is where stack comes in. So each time we see a child node, we actually push it to the stack. And each time we get like a .. operation, then we actually go up. And that means we have to pop out that label now. And in the end, the size of the stack is actually our answer because that is the depth we actually went into. So this is one way. But do we really need to use the stack here, given that we just care about the size of the stack? And there are mainly two operations that we have to take care of. Either we have to go down or we have to go up, right? So why not we just use the depth counter? Each time we see a child folder, we actually increase the depth, right? And each time we get .. folder, like moving to the parent folder, that means we have to reduce the depth. So these are the only two operations we have to take care of. And if we get a .. that means we don't have to worry about anything, right? Because we are at the same level, so that does not change. And one edge case or one case you have to think of is like when we are going up, the depth should not be less than 0, right? Because we can't go higher than main folder. So now that we have seen this, let's jump into the code part. So first thing we do is we define the depth variable. Now we start iterating over the logs. Now, if s is like .. that means we have to go to the parent folder. So we reduce the depth. But the maximum depth it can go to is the main folder, which is at depth equal to 0. So if depth falls below 0, we bring it back to 0. We can do this by using the maximum function. So either it should be 0 or whatever is the depth we get so far. Otherwise, if it's equal to .. that means folder stays the same. So depth does not change. So we will just continue. Else we are here, that means S is actually some child folder. So we go one level lower because of that. So we will just increment our depth. And once we are actually out of the loop, we just return depth as an answer. Now let's run this code. Let's submit this code. Awesome. In terms of time complexity, it is O of n, where n is the length of the logs array. The reason for this is we are just looping over this logs array and then updating the depth variable based on that. In terms of space complexity, it is O of 1 because we are not using any extra data structure to store some values. We are just using depth variable, right? And the stack-based solution will also be similar, just that instead of incrementing and decrementing the depth variable, we will be just pushing and popping the logs in the stack. And in terms of time complexity, it stays the same, but in terms of space complexity, it is O of n because in the worst case, we are storing n logs in the stack. I have provided both the solutions on my blog. The link is in the description below. Please check it out. I hope this solution was clear to you. If it was, please like and subscribe. Have a nice time. Thank you.